Hello students, in this video I'm going to do a quick revision on partial fractions. Right, let's look at what are the concepts involved in this chapter, partial fractions. Right, first of all we need to know what is the degree of a polynomial, because the degree of a polynomial will help us to determine what kind of partial fractions that we need to use. So what is degree of a polynomial? It's actually the largest index among all the terms, and this largest index is actually a whole number. So supposing if you have a polynomial that is 2x to the power of 5 plus 3x squared plus 2x minus 1. So if you compare the index 5, 2, 1, and of course negative 1 is a constant, it means it's negative 1 times x to the power of 0. Then the biggest number, 5210, the biggest number is 5. So in this example here, the degree is 5. The degree of a non-zero constant polynomial is 0. What does it mean? Supposing if a number negative 3, you can write negative 3 as negative 3 times x to the power of 0, because x to the power of 0 is 1. So in this case here, the degree of this non-zero constant is 0. Another example is the number 4. You can write 4 as 4 times x to the power of 0, so therefore the degree is 0. Okay, so in partial fractions, there are a few rules that you have to remember, to memorize. What is the first one? First of all, we need to recognize what is a proper and improper. What do you mean by a proper and improper polynomial fractions? So a proper polynomial fractions is one where the degree of your numerator is strictly less than the degree of the denominator. So one example is if you have 2x squared plus 3, then the degree of your denominator has to be more than 2, so it has to be like 2x cubed minus 1. So this is what it means, right? And what is an improper fraction? An improper fraction is when the degree of your numerator is equal meaning it could be like 4x to the power of 4 plus 3 over x to the power of 4 minus 1, where the degree is the same, or the degree of the numerator is strictly more than the denominator. So strictly more than, it means if it's 4x to the power of 4, then the highest degree at your denominator will be x to the power of 3. Right, so why is it important that we recognize what is a proper and what is an improper polynomial fractions? Right, so let's look at how we can actually write a proper polynomial fraction in partial fractions. There are 3 rules that you need to remember. Okay, if the denominators comprises of linear factors, right, so this is what you use. If your denominator comprises of a repeated linear factor, this is called repeated linear factor. Repeated linear factor means bracket ax plus b to the power of 2. And so the partial fractions that you need to use will be a over a linear plus b over the repeated. Supposing your denominator is an irreducible factor, is anything to the power of 2 plus, the operation is a plus 4 or plus 6 or plus 7, whatever. It's called irreducible. Irreducible meaning you cannot factorize it anymore, alright? Then the partial fractions that you use will be ax plus b over your irreducible denominator. So this is how you can rewrite proper polynomial fractions into partial fractions. Right, so if it's an improper, then we will have to do more steps. Right, let me erase all this. Let's make it tidy a bit. Right, so what happens if it's an improper? Right, so let's look at these questions. Right, we asked to express it in partial fractions. So let's look at the denominator. Right, we need to analyze the denominator so that we need to know which rule to apply. Right, so the denominator 1 minus x squared can be factorized into 1 plus x times 1 minus x. Okay, what we are applying here is one of the algebraic identity, a squared minus b squared, which can be factorized into a minus b times a plus b. Alright, so what we are having here as a denominator are two linear factors. Okay, two linear factors. Linear in the sense because the power is 1, x to the power 1. Alright, so there are two linear factors. So the partial fractions will be a over 1 plus x plus b over 1 minus x. So these are the two partial fractions that we'll be using, right? And then what is the next step? Yes, the next step is to find the unknown a and b. But to find the unknowns a and b, we need to combine them. We need to combine these two partial fractions into a single fraction. Okay, so the common, the LCM, lowest common multiple for your denominator, would be just the multiplications of these two linear factors. And then, of course, you have to multiply a with this 1 minus x, and then b with 1 plus x, right? So you see that this fractions, it's actually equal to this, right? And we can clearly see that the denominator 1 minus x squared is this one that we have factorized it into the two linear factors. Hence, the numerator would be equal to 7x minus 3. 7x minus 3 will be equal to a bracket 1 minus x plus b bracket 1 plus x. Okay, right. So we're going to use substitution method to find the values of a and b. So we can substitute x to be 1, because when you substitute x to be 1, basically 1 minus 1 will give you 0. So 0 times a will give you 0. So in this case here, we eliminate the constant a, leaving only b, so that we can find the values of b, which is 2. And then we're going to let x to be negative 1 to eliminate constant b, so that we can find a to be negative 5. So with these two values that we found, we'll put them back into this partial fractions. These are the two partial fractions for the answer. Right, so therefore the partial fractions are negative 5 over 1 plus x plus 2 over 1 minus x. Alright, so this is quite a straightforward question, right, using the first rule, where your denominator is linear factors. Right, let's look at the next question, where your denominator comprises of, so first thing first, you must really examine the denominator, because the denominator will determine which rules to use. So if you look at your denominator, right, the first one is a linear factor. However, the second one here is irreducible, x squared plus 4. This is an irreducible. So in this case here, the partial fractions will be 1, which is over a linear factor, and then the second one is over a irreducible factor. So how do you think it will look like? Yes, it will be a over x plus 1, which is a linear factor, and for the irreducible one, the numerator will be bx plus c. Okay, you can refer to the earlier slides if you have forgotten why is it the numerator is bx plus c. Then of course the next step is to combine them into a single fraction. Here, if you combine them into a single fractions, your denominator, your common multiple, lowest common multiple will be x plus 1 times x squared plus 4. So I need a to multiply with x squared plus 4. And then this one here, which is very, very important, you need to bracket it. Okay, if you do not bracket it, you'll make mistake in your calculation. So bracket your bx plus c, bracket the x plus 1. Okay, very important, right? And from there, you compare your numerator, which is equal to the 10x minus 5. So that explain the steps here that I have written down. Okay, and of course, then we're going to use substitution method. So there are three unknowns there, a, b, and c, right? So we can let x to be -1 to eliminate our b and c, right? Because when x is -1, basically this will be 0, so this whole chunk of thing will be gone, right? So we can find the values of a to be -3, and then we can eliminate b by letting x to be 0, right? So if we let x to be 0, b will be gone, and since we already found the values of a, I can plug it back here. Can substitute a to be -3, leave it only the unknown c, so c is equal to 7, right? So of course, after finding the values for a and c, finding b is easy. You can just let x to be 1, any values other than 0 and -1. So the smallest one will be 1, right? So from there, you need to expand this to get 2b plus 14. This one is -15, so bring over to the other side, become plus 15. So b is 3. So with all these values found, you can just put it back into your partial fraction here. Okay. Right, let's look at the next questions. Right, so let's examine the denominator. So the denominator comprises of, definitely this is, okay, before we do anything, we have to examine whether it's improper or proper. So definitely this is proper, because if you look at the numerator, it's a constant. The degree of a constant, the degree of a non-zero constant is 0, right? And here, if you look at your linear factor, this is x to the power 1, this is x to the power of 2. If you multiply x to the power 1 times x to the power of 2, you will get x to the power of 3. So definitely 0 is less than 3. So definitely this is a proper polynomial fractions. Okay, so let's look at the denominator. It comprises of a linear, and this is called a repeated linear. So what would be the partial fractions be? For the first linear, it would just be a over 2x minus 5. And then for your repeated, this is called repeated linear, it will be b over x plus 1, then plus c over the repeated linear. Okay, so we're going to combine them into a single fractions. So your lowest common multiple will comprises of 2x minus 5 and x plus 1 to the power of 2 only. Okay, um, you don't need to take this times this, because your x plus 1 is already inside your repeated linear. So you just need to have your repeated linear will do. Okay, so from there, you can get your numerator. And since the two fractions are equivalent, you can compare the numerator. Okay, so likewise, we're going to use elimination method. So to eliminate b and c, we're going to just let x to be 5 over 2. Right, basically you just let this guy equals to 0. Then from there you can find x to be 2.5, 5 over 2. Right, so this chunk of thing will be gone, this will be gone, this will be gone. So left only values of a to be found. And where do I get 49 over 4? It's when you substitute your x to be 5 over 2 plus 1, bracket square. Basically just use your calculator to help you evaluate, you get 49 over 4. So 42 divided by 49 over 4 will give you 24 over 7. Alright, so we have managed to find the values of A. Now we are left with B and C. Right, so if you look at it carefully, I can eliminate B by letting x to be -1. Right, so from there I can find the values of C, and after having found A and C, to find B is easy. I just let it to be 0. Okay, and you have to sub in your values of a and b you found earlier on, and be very careful with the algebraic manipulations. Okay, right, just try it out on your own, and if you get it wrong, compare with my working. So b is 12/7. So having found all this value, we can put back into our partial fractions. So our partial fractions is this one here. Right, so your A is 24/7. Okay, this one is a bit tricky. So I'm going to show you how to do it. So A is 24/7. You can't leave your answer as 24/7 over 2x minus 5. Okay, this is considered as not simplified. So what you can do is to make 24/7 the whole number, just multiply by 7 at the numerator, multiply by 7 at the denominator. So this will give you just 24 at the numerator, and then 7 bracket 2x minus 5 as the denominator. So another way to look at it is that 24 will be the numerator, and then 7 will go to the denominator. Just that simple lah. Okay, so let's put all our ABC back. So the partial fractions will be, okay, so like for example, b is 12/7, right? So can you see that your numerator is 12, then denominator is 7. Of course, your linear factor must still be there, so it's just 7 bracket x plus 1. And values of c is -6. So this is your partial fractions for this questions. Right, so in this question, you will see that what we are dealing of is an improper fractions. How do you know what we are dealing of is an improper fractions? Basically, if you just look at the degree of a numerator is 3, and if you were to expand this guy out, you will have x squared minus x plus 16, where the degree is 2. So when the degree of the numerator is more than the degree of the denominator, this is called improper fractions. So therefore, we have to use long divisions to break it up. Yes, to break it up into a sum of a proper fractions and a polynomial. Okay, right, so we're going to use long divisions. So your dividend, it's your x cubed, your divisor is your x squared minus 8x plus 16. All right, so what do we do? We take x cubed to divide by x squared. Take this term, divide by x squared, that gives you x, right? And then with the x found, you multiply with every single terms of your divisor. So that will gives you x squared minus x cubed, sorry, minus 8x squared plus 16x, and that will give you 8x squared minus 16x, and then take 8x squared divided by x squared again, that will give you 8, so plus positive 8, and then your positive 8 again, multiply with every term of your divisor, that will give you 8x squared minus 16x. Okay? Wait, I think I make a mistake here. 8 times x squared will give you 8x squared. 8 times negative 8 is negative 64x. Then plus 16 times 8. 128. And that will give me negative 16x. Minus and minus is positive, plus 64x. 64 minus 16 give me 48. So I'll be left with 48x minus 128. Alright, so how do I write it as a proper fractions and a polynomial? So this will be equals to quotient, which is your x plus 8. Then plus, this is your remainder, which is 48x over 48x minus 128. Over your divisor, which is your x squared minus 8x plus 16. But of course, your x squared minus 8x plus 16 is derived from bracket x minus 4 to the power of 2. Alright, so the proper fractions will refer to this part here, where I need to apply the rules of this is the proper fractions where I need to break it up into partial fractions. This is the one where I need to apply the rules of partial fractions. So we see in the next slide. Right, so if you look at these proper fractions, your denominator is actually a repeated linear factor. So for a repeated linear factor, we can break it up into a over linear plus b over repeated. Right, so like what we have done so far, we combine them into a fractions again. Right, in this case here, our lowest common multiple is bracket x minus 4 squared. Please do not put it as x minus 4 to the power of 3 because x minus 4 is already embedded in your x minus 4 to the power of 2. So you don't need to multiply x minus 4 with x minus 4 to the power of 2. Okay, the lowest common multiple of these two would just be x minus 1 to the power of 2. And of course, this one here, I need to multiply with x minus 4. And this, since I've already got x minus 4 to the power of 2 as the denominator, I don't need to multiply any extra. Okay, alright, so the two fractions are equivalent. So a bracket x minus 4 plus b will be equals to your 48x minus 128. Alright, I'm going to let, in this case here, yeah, you can use eliminations method, a substitution method, sorry, where I let my x equals to 4 to eliminate my a. So b will be just be 48 times 4 minus 128. Right, give you 64. And then you can just let x to be 0. So we found to find the values of a. So 0, then plus 64 equals to negative 128. So negative 4a will be equals to negative 128 minus 64, negative 192. So a will be negative 192 divided by negative 4, and that gives you 48. So therefore, your partial fractions will be, not to forget the quotient that we found earlier on to be x plus 8. So the partial fractions are your quotient, which is x plus 8, plus these two partial fractions. A is 48 over bracket x minus 4, and your b is 64 over x minus 4 to the power of 2. So this is how you solve this questions where the polynomial fraction given is improper.